Hello, good day, guys. You're welcome again to my channel. This is Joshua the designer, and this is where you always get your amazing structural content that makes you better every time you make contact. Right, so I am here to give you another amazing tutorial as usual, and I would like that you pay attention. Today, I'll be showing to you how we go about our rib slab designs, right? But basically, I'll be showing you a lot about rib slab in one video. I'll be showing you a lot about rib slabs in just one video. So I like that you pay attention as we go ahead. And right now, I told us in the last few weeks about the fact that we began to labor into making others better with one of our training courses, and about how to frame general arrangement drawing, and the course is still on for registration. And I like that you use the link in this very video to make registration so that you can be a part before the registration closes, right? So this class is going to make you get better in how to frame general arrangement drawings, which is one of the fundamental steps before you can begin to run into your designs and all of that, right? And this course comes with free mentorship to ensure that you are making progress where required. Right now, so I'd like to move into our training for today, our video for today. And like I said, I'll be showing you a lot about rib slab just in one video, so pay attention while we go along. Right now, before my screen, you can see a rib slab. This is what we know as a rib slab. Of course, we are all familiar with other slab types also. Particularly, none of us should be strange with solid slab, very common everywhere, right? But this is a kind of slab, also a rib slab. So I'll be showing you different thing about rib slab, including the advantages of rib slab over solid slabs. I'll be showing you the method of constructions. I'll be showing you how to take the loadings of a rib slab, right? So I like that you pay attention. In case you are making contact with my video for the very first time, I'd like you to please use the like button and ensure that you subscribe to this channel, right? So subscribing to this channel encourages us to give you more and more content to make you better, right? So I'd encourage you to please like this video and subscribe to my channel. Thank you very much. Right, so this is a rib slab, like I was saying, and this rib slab has several advantages over solid slab. Right, one of the advantage is that it is more economical, because you can see that certain volumes of concrete have been taken off and forming different shapes, as you can see here. So certain volume of concrete have been taken off, and of course it saves cost that way. So it is economical, and can also be used for longer spans, for long spans, usually greater than 5 meters thereabouts. So where solid slab cannot really span for much spans, cannot really span for much, we can use rib slab to take care of those scenarios, right? So rib slab, that is to say, it can support longer spans that solid slab may not be able to support, right? Still maintaining the economy in the consideration, right? And another advantage it has over solid slab is that, solid slab in its own thickness and that volume, it constitutes a heavier load compared to a rib slab, where most of the time thickness of the toppings itself is a very light section, so it is relatively light, so it constitutes a very light load, relatively light load, right? So, and among other advantages, so we can see that rib slab is it has its own advantage over solid slab. So in places where you might have to consider other kind of slabs for certain reasons that I've spoken about before, for span issues where you need to use a slab without having interior or internal column support, you would try to consider a rib slab. And where you want to really minimize or reduce loads, you can also use your rib slab. And also you want to maintain cost and still keeping everything intact, you can use a rib slab over a solid slab. Okay, so I'll be taking us through the method of construction, and this would take us to our code of practice. So I'll be showing us something from our code of practice, BS Victory Standard 8110 part 1, 1997. I'll be showing us something from that very code, so I want you to pay attention. So this is BS 8110 1997 part 1. So clause 3.6 speaks about the rib slab. So I'm still on the method of construction, so just stay with me. So according to this clause 3.6, there are two classifications of, or two method of construction for rib slabs, right? So I want you to pay attention with this heading. It says, to this heading, it says with solid or hollow blocks or voids, right? If you don't get that clear, let me simplify it for you. It means that rib slabs can be with permanent blocks or without permanent blocks. So if it is without permanent blocks, it can be such like I showed to us here, such like I showed to us here. So you can see that it's just the void is just there, nothing filling that space between two ribs, right? Two successive ribs, right? So that's exactly what I'm trying to say. So it can be with permanent blocks, hollow blocks, or solid blocks, right? Or might be void like I showed to you. So the one you saw previously is the one with voids, because there are nothing filling the ribs, spaces between the ribs, right? So then some might come with permanent blocks, which might be solid blocks or hollow blocks, right? So those are the two classifications. I've tried to simplify it to make this heading for this clause clear, right? Because you might not be able to get it clear at first, seeing that you have with solid or hollow or void, right? So we have with permanent blocks. So the permanent blocks could be solid and could be hollow. Then the other one is without permanent blocks, which means that the spaces between ribs are voids, right? Okay, so we can move on, and I like to show us some consideration, basic consideration that you should not forget if you want to attempt to use a ribbed slab, right? So of course, if we would find any consideration to apply to any of our structural um applications, we would need to still stick with our code of practice, so that we would not be working out of reasonable context, right? So moving right now, clause 3.6.1.3 speaks about the spacing and size of ribs. So I'll be showing you something so that you'll be able to relate with what this clause and other ones will be saying. So I want you to pay close attention to that as I show to you. Right. So if you look at this, This explains the two method of construction that I spoke about earlier. I spoke about one without permanent blocks, which exactly is this A. Can you see that the spaces between two ribs are open? So it is without permanent blocks. And the other, which is B, is rib slab with hollow blocks, and in some other cases it could be with solid blocks, right? So these two are the methods of construction as explained in clause 3.6 of the BS 8010 1997.1, right? So I want to show you something from from figure, that first figure A. Starting from this, we see this explains, this is actually pointing out the width of your rib, the width of your rib, and there is a provision for that in your code of practice. So I just want you to know that we have something as the width of our rib. Now there is also another consideration for the minimum spacing between two ribs, minimum spacing between two ribs. So you are not just seeing this greater than or equals to 1.5 meter. You're not just seeing it here. So I'll bring an explanation to that from our code of practice. Right. I just want you to see this so that by the time I begin to take you through, you'll be able to relate along. Right. So we have this. This is what we call toppings. The thin layer of concrete above your rib is the topping. So I said the other time is very light. So that what make your your rib slab relatively light. So it says it should be less than or equals to 50, right? But there is a consideration for that, right? It's not a master rule. There's a consideration for all of these in the BS code. So I just wanted to view this so that you'll be able to relate by the time I bring an explanation from the BS 8110. Right, so the depth of your rib also, there is also a consideration for that, and it says that it should be greater than or equals to four times the width of your rib. That is, it should not be less than four times the width of your rib, right? So can we go back to our code of practice so that I'll be able to show us the considerations that govern the use of our ribbed slab? Stay with me. Now, so we have the spacing and size of ribs, and the code told us that in situ ribs should be spaced at centers not exceeding 1.5 meters. Did you see that? The ribs should be spaced at centers not exceeding 1.5 meters, and that is exactly what I showed to us here. So the ribs should be spaced not less than 1.5 meters. Otherwise we could say that the rib should be spaced at a distance equal to 1.5 meters or greater than 1.5 meters, right? So that is what it's saying to us. Now let's continue. He said, and their depth, that is the depth of the rib now, right? Excluding any topping. So when we are considering the depth of our rib, we are taking out topping from the consideration, right? Excluding any topping should not exceed four times their width. So the depth excluding toppings now should not exceed four times their width. So that's exactly what I was trying to show to us here. So that the depth of our rib now excluding toppings, so that's why the measurement starts just right below the toppings, should not be less than four times the width of your rib. So that's why we're seeing greater than or equals to 4 multiplied by our width of rib, right? So that's the consideration for spacing and size of rib. Now another one says that the minimum width of rib will be determined by considerations of cover, bar spacing, and fire, right? So it will mean that whenever you are considering the width of your rib, you'll be considering the cover to reinforcement, you'll be considering the spacing of your bar and fire resistance before you will be able to arrive at the minimum width for your rib slab, which is exactly this BV, right? So I hope you get that clear. So, and in case if you have any questions along my explanations, please do well to use the comment section. I'll be right there to attend to any of your questions. And in case you're watching my video for the first time again, I would encourage that you'd use the subscribe button. If you're uh, always with us but you've not considered to subscribe, I would like that you do that now to encourage us to do more. So I've been able to bring an understanding to the considerations that we apply in our rib slab designs. So I'd like to show us something also about the thickness of the toppings, which is this I spoke about, less than or equals to 50. So I want to show us something about it. So clause 3.6.1.5 of the BS 8110 part 1 1997 told us about the thickness of topping used to contribute to structural strength, and it says that the thickness of any necessary allowance has been made for wear should not be less than those of table 3.17 of this code, and this is exactly what we are looking at here. So we can see that the table 3.17 is speaking about the minimum thickness of structural topping. So, and we have two considerations, like I told us earlier, that there are two methods of constructing our rib slab. Is either you construct with permanent blocks or you construct without permanent blocks. Constructing with permanent blocks means that you are going to use solid blocks or hollow blocks to fill the spaces between two and more ribs, while the other one means that you are going to leave your spaces void, right? So it has no permanent blocks in our application, right? So we are having something like this, something like this. So we are having something like this to be a rib slab. So we are having voids in between the ribs, and that means we are not applying permanent blocks, so it is without permanent block. So in this case, we'll be sticking to the option that suits it from this table, which is saying all slab without permanent block. So we are applying this one, and the requirement says that the minimum thickness of topping in millimeters now should be 50 millimeters, or 1 over 10 of the clear distance between ribs, whichever is greater between 50 millimeters or the result of 1 over 10 of the clear distance between the ribs. So, and that is why you see in the figure I showed to us earlier that it says that it should be less than or equals to 50 millimeters. I believe that should be clear enough for everybody to understand, right? So I'd like to move on from here and show us one more thing. Okay, so I'd like to show you this. Now this shows to us clearly the two methods of construction. So just to bring an highlight and to show to get you to understand what we're talking about, that's why I have to show you this again. So we see that the this one falls in the category of the permanent blocks. So but is it has hollow blocks in its use. The second one is with a former void formers. So, and the third one is total voids, right? So without permanent blocks, right? So the second one also is with voids. It's with voids, but these voids they are being created by permanent formers. Okay, so that's that, and I think we're cool with that. So let's go into the loadings. How we come about the loadings of a ribbed slab, having understood basic things about rib slab now. So let's go into our loadings. Okay, and before we'll be able to do that, I like that we pay attention to this very section of our rib slab. Now we can see that the thickness of our topping is 50 mm, the width of our rib is 125 mm, and the spacing between two ribs is 400 mm. Okay, so from here we can actually begin our journey in making our loadings, in obtaining our loadings. Okay, so can we begin? So having this image in our heart and at hand, we can begin to go into the loadings. And the first thing we want to understand, because I showed us from the code that the consideration for the width of our ribs and all of that comes from cover, fire resistance, and other conditions. So that's how we arrived at this. So for this particular design, we'll be making use of all this consideration. Right. So let's get into our loadings. Now, this is going to be our loadings, and I'll explain about the loading so that you will be able to get me clear. Now for the loadings now, to obtain our effective depth, we know that from what we can see here, we have 200 for the overall depth, and to have the effective depth of this rib now, we'll need to remove our cover and half of the bottom reinforcement. All right, so the cover here is showing to us that we have considered the use of a cover of 25 mm, and we use a diameter of reinforcement of 12 millimeters, right? So that is 12 millimeters divided by 2 gives us 6 millimeters, and the cover is 25 millimeters. So when we subtract the cover and the half of the diameter of the bottom reinforcement, we have 6 millimeters. So we're left with 169 millimeters for the effective depth right now. Now to consider our loadings. The self weight of toppings, of course I showed us what toppings means, which is the thin layer of our ribbed section, right? So very thin, about 50 millimeters or less thereabout. So to get the self weight of that topping, we have 50 millimeters converted to meter gives us 0.05, and we multiply by the width of that flange. So this is how it's going to be. We know this to be, so that you can understand now. I will show you, I will illustrate something to you. If I do this, what I'm trying to do is I'm trying to bring out the mid section of that particular rib. So if I bring out this mid section and I measure it, it's going to give me 400. It's going to give me 400. So don't mind my text is big. So to make you comfortable, as I would like to be comfortable too, let me do something about it. So yes, now if I deal with any section of this rib as I did with this mid one, I would have 400 as the width of the flange for that rib. So that will mean that considering the self weight of this topping, I have the thickness of that topping multiplied by the width of that flange, right? So I believe you understand now how we got the 0.4, right? And we multiply by 24, which is the norm that we do even with the solid slab, multiply by the density of concrete. Okay, so we have 0.48 kilonewton per meter that way. Now for the self weight of the rib itself, and of course we can see from this that the width of this rib is 125 millimeters. So and the depth that we obtained already is there. So we multiply the width of the rib by the effective depth and by 24 also. So we have 0.51 kilonewton per meter. Now assuming that we have the finishes of 1.2 to apply, right? So we apply that with the flange width, right? So multiply by 0.4 gives us 0.48 kilonewton per meter. That's very clear. Okay, so we'll have a total dead load. Adding the three together, we have total dead load of 1.47 and the life load of 1.5. We would have to multiply that by 0.4, right? Which is the flange width. That's carrying the toppings. Yeah, so that's 0.6 kilonewton per meter. Now to obtain our ultimate design load, we use the 1.4 GK plus 1.6 QK, and we obtain a final result of 3.02 kilonewton per meter. And with this load, we can continue to journey into our design of our rib slab. So either you want to use your software to design your rib slab, you need to even still estimate this load and apply. All right, so and now that you know how to apply, you can make another journey into your design. I believe that this is simple enough and everyone to be able to catch all that I have been able to tell to us. I am Joshua the designer, and I want to encourage you to stay around on my channel. Ensure that you subscribe, share the link with your friends, your colleagues at work, in your classroom, your friends that should get better with structural designs. It's a means to encourage us to do more. Like our very video. If there's anything that's not too clear, you can use the comment section. I'll be there to give you a feedback. And that will be all for this video. Thank you. See you in the next video. Bye.